Hello friends, this video is brought to you by www.moateaching.com.
We introduce one more algebraic method to solve a pair of linear equations, which for many reasons is a very useful method of solving these equations. If equation 1 and 2 form a pair of linear equation in two variables, then the cross multiplication method proceeds as follows. Start by considering the first variable, that is x in our equations. So write x, and under x we will write the coefficients of y and the constant term in this fashion: b1, b2, c1, c2. Now consider the next variable, that is y. So we write y, and under y we will write the constant term and the coefficients of x. We can use the same constant term as it is already somewhat under y, and we write the coefficients of x, which will be a1, a2. Next, we come to the constant term, that is c1, c2. So, corresponding to constant term, we write 1. And now we have to write the coefficients of x and y, leaving the constant term as it is. So, under 1, we will write a1, a2, which is already there, and b1, b2. Reaching this diagram is one of the important steps of the cross multiplication method. Next, we proceed by writing x, and under x multiply the values, that is b1 multiplied by c2 gives us b1 c2 minus b2 c1. Remember the steps. We have to first multiply b1 with c2 and then from that subtract b2 c1. Now this is equal to y by, consider the next pair, that is under the y values we start with c1 a2 minus c2 a1, and this will be equal to 1 by, consider the next pair, a1 b2 minus a2 b1. Once we reach this step, now we have x by b1 c2 minus b2 c1 is equal to 1 by a1 b2 minus a2 b1, and y by c1 a2 minus c2 a1 is also equal to 1 by a1 b2 minus a2 b1. From the first equation, we get x equal to B1 C2 minus B2 C1 by A1 B2 minus A2 B1, and from the second one we will get y equal to C1 A2 minus C2 A1 whole by A1 B2 minus A2 B1. If we remember the diagram, no need to remember x and y in terms of A1, A2, B1, B2. It is more important to understand the method of cross multiplication. Now we notice that denominators in x and y are same, so the following case arises. First case is if the denominator is not equal to 0. If it is not equal to 0, that means x and y will take some real values, and that means the given pair of equation will have a unique solution. This same inequality can also be written as A1 by A2 is not equal to B1 by B2. Then the pair of linear equation has unique solution. Next case is if A1 B2 minus A2 B1 equal to 0. If this condition arises, then let us see the various cases that are possible. We solve this further, we get A1 B2 equal to A2 B1, and this gives us A1 by A2 equal to B1 by B2 if it is equal to some constant k. Say we are taking some constant. Then we have A1 equal to A2 into k, or we can say k times A2, while B1 equal to k times B2. Here it is time to recollect the original two equations, equation 1 and 2. Now substitute the value of A1 and B1 in equation 1. On substitution we get k times A2x plus k times B2y plus C1 equal to 0. Now we can take out k common and get A2x plus B2y plus C1 equal to 0. From equation 2, A2x plus B2y is equal to minus C2. So let us substitute here. We get k times minus C2 plus C1 equal to 0, or C1 equal to k times C2. From this we can infer that equation 2 and equation 3 can both be satisfied only if C1 equal to k times C2. Now look at A1, B1 and C1. We see that A1 is k times A2, B1 is k times B2, C1 is k times C2. This means equation 1 and equation 2 are equivalent, and we already know that if the equations are equivalent, then any solution of equation 2 will satisfy equation 1 also, and vice versa. That means any solution of 1 will satisfy 2 also, and that in this case the equation has infinitely many solutions. In other words, if A1 by A2 is equal to B1 by B2 equal to C1 by C2 is equal to some constant, then there are infinitely many solutions, while if say C1 is not equal to K times C2, then what happens is that the solution of equation 2 is not the solution of equation 1 and vice versa. Therefore, the pair of linear equation will have no solution, and we can write this as if A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, then there is no solution for the pair of linear equations. Let us summarize. For the given pair of linear equations, equation 1 and 2, if A1 by A2 is not equal to B1 by B2, then the equations have a unique solution. If A1 by A2 equal to B1 by B2, then check for C1 by C2. If they are also equal to C1 by C2, then the equations have infinitely many solutions. But if A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, then there is no solution of the pair of linear equations. We shall now solve some examples using cross multiplication method and understand properly. Let us read the question. From a bus stand in Bangalore, if we buy 2 tickets to Malleshwaram and 3 tickets to Yeshwanthpur, the total cost is 46 rupees. But if we buy 3 tickets of Malleshwaram and 5 tickets to Yeshwanthpuram, the total cost is rupees 74. Find the fare from bus stand to Malleshwaram and to Yeshwanthpur. Let us start by assuming that the cost of ticket to Malleshwaram be rupees X and cost of ticket to Yeshwanthpur be rupees Y. Then, according to the given conditions, we get the following equations. Now let us solve this equation by cross multiplication method. For that, let us bring them to the standard form, that is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Now we draw the diagram. Write x and under x leave the coefficients of x and write the coefficients of y and the constant term. We get 3, 5, minus 46, minus 74. Now write y and under y write the coefficients of constant term and x terms. But constant terms are already written, so we write the coefficients of x, which is 2 and 3. Now write 1 and under 1 leave the coefficients of the constant term and write the coefficients of x and y. Since the coefficients of x are already written, we have to write the coefficients of y, that is 3 and 5. Now that the diagram is drawn, it is easy to find the values. We write x under x, multiply 3 with minus 74 minus 5 into minus 46 equal to y by minus 46 into 3 minus 74 into 2 equal to 1 by 2 into 5 minus 3 into 3. Now simple mathematics is left to be done. We have x by minus 222 plus 230. Why? Because minus into minus will become plus. Similarly, y by minus 138 plus 148 equal to 1 by 10 minus 9. Solving these further, we get x by 8 equal to y by 10 equal to 1 by 1. Now we can write this as x by 8 equal to 1 by 1 and y by 10 equal to 1 by 1. So x is equal to 8 and y equal to 10. That means the fare from bus stand in Bangalore to Malleshwaram is Rs 8 and to Yashwantpur is Rs 10. Let us read the question. For which value of p does the pair of equations given below has unique solution? Let us recall the condition for pair of equations to have unique solution. That was if a1 by a2 is not equal to b1 by b2, then the equations have unique solution. We have to find the value of p such that the given equations have unique solution. So that means our given equations satisfy this condition, and let us substitute the values. a1 by a2 means 4 by 2 should not be equal to p by 2. If we solve this further, we get 8 should not be equal to 2p and 8 by 2 should not be equal to p, or p should not be equal to 4. Therefore, for all values of p except 4, the given pair of equations will have a unique solution. For what value of k will the following pair of linear equations have infinitely many solutions? Let us recall that a pair of linear equations have infinitely many solutions if a1 by a2 equal to b1 by b2 equal to c1 by c2. We have to find the value of k such that equation 1 and 2 satisfy this condition. Let us substitute the values. K by 12, that is a1 by a2, is equal to 3 by k, that is b1 by b2, is equal to k minus 3 by k. Actually it is minus k minus 3 by minus k, which gets cancelled. So that is why k minus 3 by k. So now we have k by 12 equal to 3 by k and 3 by k equal to k minus 3 by k. From the first condition we get k square equal to 36, or k is equal to under root of 36. That means k can take values plus 6 or minus 6. From the second condition we have 3k equal to k into k minus 3, which gets converted into a quadratic equation, that is k square minus 3k equal to 3k. So k square equal to 6k, or we can say k square minus 6k equal to 0, k minus 6 equal to 0. That means either k equal to 0 or k equal to 6. Now from here, k can take value 0 or 6 or plus 6 or minus 6. The value of k that satisfies both the conditions is k equal to 6. So we write at the end of the answer the value of k that satisfies both the conditions is k equal to 6. So for k equal to 6, the pair of linear equations has infinitely many solutions. We shall now discuss such pair of equations which are not linear but can be reduced to linear form by making some suitable substitutions. Look at the equation 1 by 2x plus 1 by 3y equal to 2 and 1 by 3x plus 1 by 2y equal to 13 by 6. This pair of linear equation is not linear as x is coming in the denominator and both the equations are not comparable to the general form of linear equation ax plus by plus c equal to 0. But we can convert these two equations into linear equations by substituting 1 by x equal to p and 1 by y equal to q. Let us look how it gets converted. Look at equation 1. We have 1 by 2x that can be written as 1 by 2 into 1 by x plus 1 by 3y can be written as 1 by 3 into 1 by y equal to 2. Now making the substitution 1 by x equal to p, we get 1 by 2 times p plus 1 by 3 times q equal to 2. We can solve this further, take the LCM. LCM is 6. So we get 3p plus 2q equal to 2 or 3p plus 2q equal to 12. Now this is our equation number 3, and similarly we can proceed with equation 2 and reach another equation 4. Substitute 1 by x equal to p and 1 by y equal to q. We get the following equation. Solving this further, we get 2p plus 3q whole by 6 equal to 13 by 6 or 2p plus 3q equal to 13 as equation number 4. Now we can solve equation 3 and 4 by any of the known methods, that is substitution method or elimination method or cross multiplication method, and then find values of p and q and back substitute in the assumptions. To finally find the value of x and y.